Here's problem 9.23. A 5-gram particle moving 6 meters per second collides with a 2-gram particle initially at rest. After the collision, each of the particles has a velocity that is directed 30 degrees from the original direction of motion of the 5-gram particle. What is the speed of the 2-gram particle after the collision? Alright, so let's see what we got here. Mass 1 is 5 grams. Moving with initial velocity, one initial in the x direction, of 60 meters per second. It's going to collide with mass 2, which is 2 grams, and that has initial velocity 2 in the x direction of 0. And then we're going to have one particle go off this way at a 30-degree angle, and another particle go off this way at a 30-degree angle. So let's have mass 2 go off this way and mass 1 go off this way. So we'll have a V1 final over here and a V2 final over here. So that's the way things look like initially and finally, this being a 30-degree angle as well. So if we were looking strictly in the x direction, we would have that mass 1, velocity 1 initial in the x direction, plus mass 2, velocity 2 initial in the x direction, is equal to mass 1, velocity 1 final in the x direction, plus mass 2, velocity 2 final in the x direction. Velocity 2 initial in the x direction is 0, and mass 1 is 5, and moving at 60, so we have 5 times 60 meters per second is equal to 5 times V1 final cosine 30 degrees plus 2 grams times V2 final. It's actually going to be a negative cosine 30 degrees, or no, positive still, because it's in positive x direction. So cosine 30 degrees, correct. So it looks like that. Okay. So what do we have? Let's see. So it looks like we have 300 is equal to 5 cosine 30 is 4.33 V1 final plus, and 2 cosine 30 is 1.73 V2 final. Alright, so far so good. We have two unknowns in this equation. So let's look at the y direction. In the y direction, we have no initial momentum, and afterwards we should also have no final momentum, but we have equal and opposite momentum by the two particles. So we have mass 1, V1 final in the y direction, plus mass 2, V2 final in the y direction. So we have 0 is equal to mass 1. Now V1 final in the y direction is going to be V1 final sine 30 degrees plus mass 2. V2 final in the y direction is going to be V2 final times a negative sine 30 degrees. In other words, that velocity, V2 final in the y direction, is going to be a negative velocity. It's going in the negative y direction. So if we divide through by the sine of 30 degrees, we have that 0 is equal to 5 grams times V1 final minus 2 grams times V2 final. In other words, 2 V2 final is equal to 5 V1 final, or V1 final is equal to 2/5 V2 final, which is 0.4 V2 final. Alright, nice to know. Let's plug this in to our other equation. So we're going to have 300 is equal to 4.33 V1 final, which is now 0.4 V2 final, plus 1.73 V2 final. So V2 final is going to equal 300 divided by 4.33 times 0.4 plus 1.73. And what is that? 4.33 times 0.4 plus 1.73 is 3.46. So we have 300 divided by 3.46, and that is 86.65 meters per second. So that is the final velocity of particle number 2, 86.65 meters per second. That is our answer for the final velocity of particle 2, 86.65.